All right, so what I want to talk about today for you guys organic is the elimination reaction. So like I said, we're talking about the different types of reaction. We've done substitution and oxidation yesterday. Today I want to talk about elimination. Elimination gets a little bit of, it's a little bit complicated because now we're going to have to integrate some extra rules, which is dativs and things like that. So unfortunately, I had forgot to bring over the summary table, which is a little bit annoying. So I'll just pull that up with you guys. We want the reaction scheme map, and we want the identification. Okay. So, oh, I did choose the right color. That was interesting. All right. So what we talked about yesterday, if you guys remember, is we were talking about the different ways we can convert from one organic molecule to another. The first one we were talking about was the substitution reactions, which is taking one thing and swapping out for something else, which actually I think I do have the notes there. Did I? Yes, I did. There we go. There we go. So see, substitution, we took that guy and we swapped it out for that guy, or take this guy, swap it out for that guy. Exactly as it sounds, substitution. We also talked about oxidation very quickly, which is taking this and converting it into a carboxylic acid. That's the only oxidation reaction you have in your reaction scheme. So it's a nice, hopefully easy one to remember. With that, in order to do that oxidation, you either need permanganate or you need dichromate. Again, these can be used as identification tests because those are the only things that will react with it, with the exception with an alkene, and that's what we're going to be talking about today. So, with elimination reactions, what is happening is you have a molecule. Get me some more paper. Grabbing my thing. Okay. So with elimination reactions, you have a saturated molecule. Remember, when we say saturated, we're talking about a molecule that has all the bonds it could possibly have. It is then becoming an unsaturated molecule, meaning that you could still add things to it. So say, for example, if I have an alcohol, that is a saturated molecule. We have maximized the number of bonds that those carbons can have. In an elimination reaction, it sounds like what it's doing, which is taking things away. You are eliminating things from the molecule. So in this case, we are eliminating, say, for example, an OH and a hydrogen. By eliminating those two things from the molecule, I can now form a double bond, which is our alkenes. So that is an elimination reaction. So elimination reactions are removing stuff from saturated molecules to make them unsaturated. All right, this could in theory work with something going into an alkyne, which is a triple bond, but in general, we don't do the alkynes in the reaction schemes and stuff. So that's what we're looking at here. Are we okay with that so far? All right, so when we're looking at our flow chart, the elimination reactions are this one here, alcohols to alkenes. In order for that reaction to occur, you need concentrated sulfuric acid because that's going to be ripping things off the molecule. So we have to start memorizing these reactions. So that one there is an elimination reaction. The other elimination reaction is you can do a haloalkane to an alkene. In that case, I will need KOH and alcohol. It's really important that's an alcohol because if it's not an alcohol and if it's in water, you have a substitution reaction instead. So it's really important that you're mindful of what you're dissolving the the potassium hydroxide into. Do you want me to repeat that one more time? Okay. So if my potassium hydroxide is in alcohol, it will remove the haloalkane and hydrogen from a neighboring carbon and form a double bond. If I have potassium hydroxide in water, it's going to take the haloalkane off and substitute it in for an alcohol. This here is a common question on the exam that I see. Why does it make a difference if you have the haloalkane with KOH and alcohol versus water? So it's a very common question that you're going to get. Are we okay with that so far? So you guys should have the sheet from the other day. So the only two that we're thinking about for elimination are these two here. Okay? Looking at these, neither of these two will help you do any sort of identification, so there's no tied identification test to it. Okay? So that's kind of the downside. Cool. The other thing I want to talk about that you guys would have seen is Zaitis rule. So Zaitis rule is talking about an unsymmetrical alkene and what's going to happen when you remove the OH. So let me give you guys an example. So let's say I have a 4-carbon chain like that, and I have an OH. So that's what my molecule looks like. Are we okay with that so far? Let's say I mix sulfuric acid, concentrated, in there. Now I'm going to remove an OH from that molecule. So I got to remove this guy. This carbon's going to be involved in a double bond. Now we know that a double bond cannot form with just one carbon, you need two. There are two neighboring carbons, so there's actually two different options for where this double bond is going to go. With that, we now need to use something called Zaitis rule. So Zaitis rule is you look at both of the neighboring carbons and you count how many hydrogens are attached to it. This one has 1, 2, 3. This one has 1, 2. You only count what is directly attached to that carbon, nothing else. The way Zaitis rule works is that the poor are going to get poorer. So the one with the fewer number of hydrogens is more likely to lose another hydrogen. It's a very kind of sad aspect of life. So the major product, you are more likely to lose one of these hydrogens and for the double bond here. So major, meaning it's formed in a higher amount. So you get a larger percentage of that product. So the first thing I make is CH3, CH, double bond, CH, CH4. So that's my major product. The minor product, because every so often, we finally get some justice, someone gets indicted, and the rich lose their money. So in that case, you can lose the hydrogen from carbon number 1, which is the rich one. If that is the case, you have a minor product, which you're going to instead get the double bond on carbons number 1 and 2. See how that happens? So that is Zaitis rule. The other way to remember is the poor get poorer. So just look at your two organic molecules. Look at your two carbons. See which one's poor. That's how you do that one. The other thing is they often ask this question as another kind of layer. Which of these two can form major minor products? So geometric isomers. This guy cannot because it has 2 hydrogens. This guy can form geometric isomers. So not only is it going to form a major product, you're going to get 2 products here because it got major minor. Cis trans isomers. So that's what we're looking at. For you guys, just FYI, before the bell goes, there's those SciPad pages that wrong lesson. There's SciPad pages that tie on to what I've just talked about. There's also collated questions from No Brain Too Small that you can start doing. I've also, like I said, put a CPR quiz up there so you guys can practice doing that. Something to keep in mind is that I haven't made a copy of this for each person on Google Classroom because people are doing different things. So when you guys do the CPR quiz, make a copy and attach it to the assignment so I know I can mark it. Okay? That's us. Have a good weekend.